Hi friends, this is GK Naidu. Today we are going to discuss about of the HVAC. Uh, so that is the heating, ventilation and air conditioning system. So how we are saying that is HVAC. So simply to say that it is mainly referred to as climate control as a process of treating the air to control its the temperature, humidities, cleanliness, and distribution to meet the requirements of the conditioned space. So that is the main motive of our particular HVAC. So in our HVAC, mainly focusing on the particular some calculation while we are going to install our while we are going to install the HVAC system. So first let we do the some calculation before installation. So what type of calculations are there uh, for conditioning of the our particular space? So those are the first one. Just let me see that is the some terminology is there related to that. That is the heat. So all are well known aware of the particular heat. So that means it is the energy transit from higher temperature objects to the lower temperature objects. And this may also occur number of mechanisms. Those are the conduction, convection, radiations. And second one is the sensible heat. So it is a kind of heat that increases the temperature of air. Uh, Simply to say that it is the molecular excitation of a given mass of the solid, liquid or gases. Molecular excitation of given mass of the solids. So and next one is the latent heat. So uh, uh, heat is present to increases the moisture of air. So it may simply to say that is the increases the moisture of air. So it changes the matter from the solid to liquid or liquid to gases. Next one, enthalpy, sum of sensible and latent heat of a substance. That is known as the our enthalpy. Next one, dry bulb temperature. So simply to say that it is the temperature of air measured by thermometer freely exposed to the air. And wet bulb temperatures, the temperature registered by thermometer whose bulb is covered by wetted wick and exposed to a current of rapidly moving air. Okay, that is the wet bulb temperature. And dew point temperature, so the temperature at which the condensation begins when the air is cold. And relative humidity, so simply to say that actual vapor pressure of the air vapor mixture to the pressure of the water vapor when the air is completely saturated at the same dry bulb temperature. And next one, that is the main thing, that is the units. Coming to the units point of view, that is the what is the calorie. So that means simply to say that uh, calorie means it is the amount of energy required to rise the temperature of 1 gram of water from 14.5 degrees to 15.5 degrees. Okay. So that is the our standard atmospheric pressure is almost 14.7 psi. Okay. And okay, ORR 1.033 kg per centimeter square. And another uh, property is BTU. So BTU means the energy of amount of the amount of energy needed to rise the temperature of 1 pound of water. The amount of energy needed to rise the temperature of 1 pound of water from 58.5 degrees Fahrenheit to the 59.5 degrees Fahrenheit under the standard pressure of 30 inches of mercury. That means our atmospheric pressure. under the atmospheric pressure. So BTU stands for British Thermal Unit. BTU stands for British Thermal Unit. So here there are some okay, some our BTU. So one BTU equals some conversions are there. So that is the our one BTU equals to 0.252 kilocalories, or our 1 kilocalorie equals to 3.96 BTUs, and 1 watt equals to 0.00948 or 9.48 into 10 power minus 4 BTU per seconds, and 1 watt equals to, similarly to write another conversion, that is the 2.84 into 10 power minus 4 tons of refrigeration. So those are the conversions are helpful while doing the problems. So now coming here. So now we are going to discuss about of the main problem. So how we are, what, okay. Before going to install our HVAC system, let we find out these total details. So that is the, our problem is, just have a look. So that is the building of 35 feet wide and 73 feet long and 8 feet of the height is constructed with the concrete 4 inches thickness and a polyester installation, that is the 2 inches thickness on each side. The building has the 4 windows east and 16 windows north, measuring by 2.5 by 4 square feet. There are 20 persons in the, there are 20 persons working in the office. So the conditions are dry bulb temperature at the inside 80 degrees Fahrenheit and relative humidity is 50 percentage, and outside is dry bulb temperature 95 degrees Fahrenheit and dew point temperature is 75 degrees Fahrenheit. So ventilation, so that is the supply air is let they give the one condition, supplying of the air is the 65 degrees Fahrenheit minus dry bulb temperature, and air handling unit, let you assume that is the 4000 CFM per AHU. CFM means cubic feet per minute and AHU means air handling units. So and other parameters are average electrical usage, that is the 1 watt per square feet, and human activity per person 180 BTU per hour, and infiltration rate, let us assume 20 CFM, and air density 0.075 pound per cubic feet at 80 degrees Fahrenheit. And again, they are also giving that this is all are given the our input parameters. Later, they may mention their thermal conductivities and thermal resistances and what are the coefficient values are there regarding the particular usage materials and components. So that is the our material point of view. Okay, polyester wall sides 2 inches. Okay, so that is the thermal conductivity and siding. So that is the concrete point of view, wall point of view, drywall point of view, pine point of view. Okay, so that is the insulation point of view, sheathing point. Okay, uh, sheathing for 0.5 inches, that is the glass point of view, roof point of view. So let they assign, okay, let they give the those total resistant values regarding the particular uh, components. So now we are going to find out the first those resistance, total resistance values. So that is the first one, considering that for a typical 2 by 4 concrete frame wall. So that is the concrete frame wall related. Just let me take so that is the Ri equals to, okay, inside of the resistant values are, that is considered as here, that is the 1 by Ri. So that is the 1 by Ri inside. So that is the, so just we see that Okay, guys. So first we have to find out our thermal resistance for our concrete wall. That is the 4 inches of the concrete and 2 inches of insulation by the help of particular formula. That is the R total value. That is the R1, R2, R3, R4. Okay, R5. So then let they take the particular calculation by finally to get the value, that is the 26 BTU per hour square feet Fahrenheit degrees Fahrenheit. So that is the R total is there, resistance calculation. After the calculation of resistance values, let they find out the our sensible loads. Those are the just we have to see the our sensible loads. So what are the components are under the our particular sensible loads? Those are the what component, that means which are having, okay, enhancing or increases the temperature of air. So those are the our walls, floors. Okay. So those all are doing that particular thing. So let we see that. So first we have to find out the wall point of view. So that walls is here. So only calculation of wall. So there is a small error here. So that is the and okay. This is the not only the, this is the not windows. This is for wall actually. Okay, this is for wall. So in this east wall, so that is the our east wall value is let me see that. So that is the formula of this, okay, load, sensible load for east wall, okay, wall point of view, that is the A into T naught minus Ti by R. So that means area of the building minus area of the window by window into T naught minus Ti by R. So why? Because the what are the wall dimensions are there? In that wall dimensions already, okay, just let me eliminate the our window dimensions. So then only that is that portion only we are having the particular wall. So that's why we are eliminating the window area. So for find out of the east wall, so just have a look here. That is the east wall dimensions are 8 into 35 feet minus 4 windows are arranged in our east wall. So 4 into 2 by 4, 2.5 into 4. Okay, 2.5 by 4 sizes of the windows are there. Into our output temperature, our output temperature is the 95 degrees Fahrenheit and the input is the 80 degrees Fahrenheit by our thermal resistance, that is the 26. So while we do the particular calculation, let we get the 138 BTU per hour. And similarly to find out the north wall point of view. So north wall, the dimensions are 8 into 73 feet minus number of windows are arranged in our north wall, that is the 16. So 16 into 2.5 by 4. So into T naught minus Ti, that is the 95 minus 80 by 26. So then we get the 245 BTU per hours. And let me calculate the our, okay, this is the wall, okay, not windows, okay, this is the wall point of view. So there is a small error here. So that is the our, okay, wall. Just this is wall related. And now going to find out the windows point of view, window sensible heat. So sensible load of the windows. So that is the, let me take the that formula, that is the A into U into T naught minus Ta. So it is also similar to that. The smallest amendment is here there is a presence of our coefficient, thermal coefficient, while we are using the that windows. So generally the windows is having the particular materials we are generally use it to the glass. So that is the coefficient of okay, heat transfer coefficient is there. So that is the 1.13 and the area is the 200. Why? Because 20 windows are totally arranged in our particular space. So 200 into 1.13 into 95 minus 80 degrees Fahrenheit. So let we find, okay, let we get that. That is the 3390 BTU per hours. So this is the wall sensible heat and window sensible heat. Now we are going to find out the our, okay, infiltration of the outside air. So that means that infiltration is happen while we are having the any leakages or any cracks of our particular cabin or okay space. So then that is considered as the, let they assume that 20 CFM for the leakage rate. So for that assumption, so let they find out the sensible heat, that is the 1.08 into CFM into T naught minus TA. So that is the CFM value already they assumed here, that is the 20 and 1.08. Okay. So what are the MCP is there? So that is the 1.08. Okay. 1.08 into 20 into 95 minus 80. So that is the value has arrived here. That is the 330 BTU per hour has arrived while doing the calculation. So later, medium size building considered here. Let they take electrical usage. So now we have to find out the electrical usage sensible loads. So that is the 1 watt per hour is the, okay, 1 watt hour. So that means that 1 watt hour is also converted into the in our BTU per hours. So that is the 9.48 into 10 power minus 4 BTU per second already there. 1 watt equals to. So that is the per second we may get the particular value 9.48 into 10 power minus 4. That means when we are multiplying with the 3600, then we get the hour, okay, hours in our particular electrical usage sensible load, that is the 3412 BTU per hours. So next and some other components are there. So that is the, so now we want to find out the some other sensible loads, that is the 3.412 into area. So so that is the our area is the, okay, okay, that is the light, that means a solar point of view, let they give here, that is the 3.412 into A. So that is the 35 into 73 feet. So that sensible load is the 8717 per hour. And occupancy per persons. So while entering into the number of persons, then they will also release the some heat. So that is also sensible heat. So that occupancy point of view, we should get the 4000 BTU per hours. And another sensible load is ceiling point of view. So that is the, let we see that AU into T naught minus TA ceiling point of view. So that ceiling is also 35 into 73 area, and that thermal resistance is the 0.23, and 95 minus 80 is the our output and input of the temperatures. So now finally to get 8815 BTU per hours. So these all are sensible heat loads uh, to consider the, okay, in our particular cabin space. So now now we want to add on the those all the sensible loads, then find out the total sensible load value. That is the 25,635 BTU per hours. Now we are going to find out the latent loads. So that is the sensible load value is the 25,635. Okay. Now going to find out the latent loads. So in that latent loads, what are the components generally there in our latent load point of latent heat loads? So that is the latent heat means simply to say that it is also a kind of heat, but it increases the moisture of air. So by the our particular usage components. So in this for light activity, the people produces a latent heat also. So that latent heat means that is happen by their respiration system. So that is the per person 180 BTU per H. So that value, okay, let me find out that value per person 180 and 20 persons are there. Okay. And and another things are kitchen appliances, so are also producing the latent heat. So let we find out the those value also. So that is the kitchen appliances. What are the kitchen appliances are there in our commercial building? That is the dishwasher is there, oven is there, and coffee maker is there. So let we find out the those all the latent loads. Okay, so that is the 420 BTU per hour and 1200 BTU per hour and 3080 BTU per hour. So now we have to find out the that person's point of view 20 into 180, that is the 3600 BTU per hour, and latent heat point of view 4700, and infiltration humidity load. So then that means infiltration. So that is also one of the latent heat load is there. So that formula here, like let we take that 4840, and that depends on the um, 4840 into CFM into W naught minus WI. So that is the our specific volume point of view. Okay. Uh, So while we are taking the our particular dry bulb temperature is at 80 degrees Fahrenheit and 50 degrees of RH relative humidity, let we find out the our these okay, our output values, that is the our WI and W naught. So by the online web psychometry chart, so that is the our inside is the 76.8 gram per pounds, and outside is the 131.8 gram per pounds. So let me find that for okay in our pounds per pounds. So for find out of the pounds per pound, then it may also arrive here 0. Our inside value is the 0.011, and outside is the our 0.19, 0.019. And coming to the our leakage rate point of view, 20 CFM is assumed here. So then the resulting latent heat is gained here, that is the 4840 into CFM into W naught WI. So that is the our 774 BTU per hours. And now we are add on the these all the things. So now we have to find out the latent heat also. So that is the our 3600 uh, and for persons, and 4700 for appliances, and 774 per particular okay infiltration point of view. So these all are while we are adding on the particular loads, then that value has arrived here 9074 BTU per hour. So that is the value related to the our latent heat loads. So now we are going to find out the refrigeration load. So that means latent loads are there and sensible loads are there. So our refrigeration load, how much of refrigeration load is required for overcome the total those heat load, okay, sensible and latent loads for maintaining the temperature. So that is the first we will find out the HI and H naught enthalpies by using the online web psychometry. So that is the our inside dry bulb temperature is okay 80 degrees Fahrenheit, and our relative humidity 50 percentage, and dry bulb temperature at outside is the 95 degrees, and dew point temperature is the 75 degrees Fahrenheit. So from inside point of view, enthalpy is the 31.2 BTU per pounds, and outside point of view 43.5 BTU per pounds. So those are the enthalpies have arrived while we are checking with the online web psychometry chart. Now, second, let we find the our ventilation flow. So that is the sensible ventilation point of view. That is the 1.08 into CFM T naught minus TI. So in that the unknown is CFM. So Q sensible by 1.08 into T naught minus TI. So then CFM equals to Q sensible already calculated 25,635, and 1.08 into 95 minus 80. Okay, so that is the 15 degrees Fahrenheit. That value is CFM, almost value is the our 1582. So that is the CFM cubic feet per minute only. So let me find the hour point of view, that is the 94,922 cubic feet per hour. So So that is the CFH value. So when we find out the refrigeration load, that is the CFH into rho air into H naught minus HI. So just we have to substitute those values. That value is refrigeration load value is the 87,564 BTU per hour. So now we want to find out the total heat loads. So that is the our total heat load points of view 4.5 into CFM into our H naught minus HI. So 4.5 into, so that is the our CFM 1582 recently arrived here. That is the 1582 total heat point of, and 43.5 minus the 31.2. So that is total loads. Total load value is the 87,564 BTU per hour is here. And now considering the total heat load here, that is as sensible heat load and the air condition loads are there, are the it is the sum of sensible and latent heat loads. So Q load equals to sensible plus latent. So that is the our Q load equals to total load equals to sensible is this is the recently to arrived here. This is the 87,564 total heat load and latent is the 9074. So that total value is the 96,638. 96,638 BTU per hour. So now we want to find out the tons of refrigeration. So that is the our total load is required. That is the our total load. So that is the 96,638 BTU per hours. So 96,000 tons of refrigeration is the 12,000 is there pounds. So that is the 96,638 by 12,000. So then let me take that 8 tons of refrigeration is required for conditioning of the total space. So why? Because why we are indicating as the our 12,000, that means here. So the ventilation equipment is based on the tons of cooling required. So that produces the 400 CFM per tons of air conditioning. So since 1 ton of cooling equals to 12,000 BTU per hour, 1 ton of cooling ice. So that may takes to 12,000 BTU per hour. So that is also equivalent to 400 CFM per hour also. So that is the calculation is there. That's why we are multiplying with the 12,000. So CFM ventilation point of view, so that is the 96,638 into our 400 by 12,000. So let we get the value, that is the 3,221 CFM. It occupies almost 3,200 to 21 occupies them. The system assumes here, we are assuming but 4,000 CFM per air handling unit. Then tons of refrigeration is 4,000 CFM by 400 CFM per ton. 400, then it may occupies the almost 10 tons. So one AHU is one AHU unit is required for maintaining the particular space. So while we do the conversion, so that is the our kilowatt point of view. 35 kilowatts of power is generally used for doing the functioning of the our HVAC. So those are the details are very important before going to installing the our HVAC unit. Thank you guys.